Hello everyone, I am Akash, and in this video I'll be showing you like how you can build a model from scratch using linear regression. So if you are someone who is fascinated by like how these models work and how we can build our own model, so in this video I'll be showing you all these things. The model will be simple. The main aim of this video is like how you can get a grasp, how you can get a perfect understanding of how to build a model from scratch. So in this video we'll be building a simple model, like we will be given, we will be giving a new height to our model, and he have to predict a new weight according to it. So let us start this video. So first of all, let me make myself smaller so you can see. We'll be using uh, VS Code. So I have made a separate folder for this video YouTube project. So हम start करेंगे by making a file. So let us give a name project.ipynb. सो हम अपना जो कोड है वो लिखना चालू करेंगे जुपिटर नोटबुक में. सो फर्स्ट ऑफ ऑल, अगर वो आपको स्टार्ट करना है तो आपको कुछ लाइब्रेरीज हैं जो आपको इंपोर्ट करनी पड़ेंगी. सो लेट मी डू दैट. फर्स्ट इंपोर्ट numpy as np and import pandas as pd. This library we will be using in writing the data frames or our data set. Then import matplotlib dot pyplot as plt and import cbone as sns. So let me first of all, yeah, now these libraries are we have imported. So this is a data set that we'll be working. We'll be given some weight, and by that weight we have to predict the corresponding height to that. So first of all, read this data frame. So for reading we'll be using pandas. So pd, like pd dot read underscore csv, and will be given the complete path of this. और हम इसको नाम देंगे डेटा फ्रेम, अपना जो डेटा फ्रेम है. अब हमने ये डेटा फ्रेम, अब हम देखते हैं अपना डेटा फ्रेम कैसा दिखता है. तो हम df डॉट हेड से देख सकते हैं कि हमारा डेटा फ्रेम कैसा दिखता है. टॉप 5 जो हमारे एंट्रीज हैं वो हमें दिखाई देंगी इससे. सो हमारा वेट है, वेट के कोरस्पॉन्डिंग हमें हाइट दी हुई है. सो हमें अब हम ऐसा मॉडल बनाएंगे लीनियर रिग्रेशन से कि हम उसे हाइट दें और हम उसे वेट दें और उसके कोरस्पॉन्डिंग वो हमें हाइट रिटर्न कर दे. तो उसके लिए सबसे पहले जो हम क्या करते हैं, हम जो हमारा ये डेटा सेट है ना, इसमें हम फीचर इंजीनियरिंग करते हैं. फीचर इंजीनियरिंग एंड ईटीए, बट आई हैव ऑलरेडी डन इट फॉर यू, सो दैट दिस वीडियो डिडंट गेट टू मच लॉन्ग. आई हैव ऑलरेडी डन ईटीए एंड फीचर इंजीनियरिंग. अब उसके बाद हम क्या करते हैं, उसके बाद हम इसको अपना इंडिपेंडेंट एंड डिपेंडेंट फीचर्स में हम हमारा जो ये डेटा सेट है इसको ब्रेक करते हैं. सो सबसे पहले इंडिपेंडेंट फीचर हमारा क्या है. इंडिपेंडेंट फीचर यानी कि जो हम इनपुट देंगे उसे इंडिपेंडेंट फीचर्स एंड कोरस्पॉन्डिंग आउटपुट दैट विल बी गेटिंग दैट वुड बी हमारा दैट वुड बी डिपेंडेंट फीचर. सो लेट अस ब्रेक इट इनटू इंडिपेंडेंट एंड डिपेंडेंट फीचर्स. सो एक्स को हम इंडिपेंडेंट फीचर कह देते हैं. तो हमारा जो वेट है वो हम वेट को किस में दे देंगे, वेट हमारा यहाँ पर बन जाएगा डिपेंडेंट फीचर, इंडिपेंडेंट फीचर. और हमारा जो वाई बना देंगे हम इसको, वाई जो है वाई को हम असाइन कर रहे हैं एज अपन डिपेंडेंट फीचर. So one thing that you have to keep in mind, like this independent feature you have to make it a data frame, and this dependent feature you have to make it a series. So this is the difference that you have to build. Now after this you have to break this data set into test and train data set. Like you have to do a test train split. So for doing that we have to import one library, and that library we have to import something to test train split. For that you can move to let me first of all, here is something like independent and dependent feature, and then like yeah, this is the library that you have to import. Yeah, from sklearn.model underscore selection you have to import test and train split. Now after doing this you have to like x train comma x test comma y underscore train comma y underscore test. This would be like equal to what? It would be equal to test train and test split. ट्रेन टेस्ट स्प्लिट, और इसमें हम क्या देंगे, इसमें हम अपना जो हमारा इंडिपेंडेंट एंड डिपेंडेंट फीचर है वो हम इसमें प्रोवाइड करेंगे. लाइक दिस इज़ अवर डिपेंडेंट इंडिपेंडेंट फीचर, दिस इज़ अवर इंडिपेंडेंट फीचर. एंड आफ्टर दैट हम एक और पैरामीटर जो हम इसमें देते हैं कि हमें रैंडम स्टेट क्या चाहिए. लाइक रैंडम स्टेट मतलब जो अगर जो मैं कोड लिख रहा हूँ वही आपको मिलेगा डेटा फ्रेम. इट इज़ लाइक दैट. एंड आफ्टर दैट वन मोर थिंग, लाइक it is having one more input, train size. Like what should be the train size? So let me give it 0.25. now you can see your x train data dot shape. So our x data set, our x column has been changed into two, has been divided into two categories, x train and x test. So you can see x train shape here. Here 5 rows are there and 1 column is there. Now after doing this we have to do standardization. Like we have to apply z score to this train and test independent features. For that you have to import from sklearn dot model selection import standard scalar. No, from where you will be getting this. So let me first of all see that where you will be sklearn dot pre-processing, sklearn dot pre-processing import standard scalar. Now we have to make an object of this scalar. Now after doing this, what we have to do, we have to give our x train and x test to this so that normalization may happen. So for doing that we have to use this scalar function scalar, and using this we have to give scalar dot fit underscore transform, and here we will be given our data x train, and we'll make x train equal to this only. After that similarly we have to do for test data also, scalar dot transform x underscore test data. Now normalization has done. After doing normalization you have to import your model. Like we will be using here linear regression, so you have to import that linear regression model over here. So for that you have to import this library linear regression from sklearn.linear model, and after that you have to make an object of this. So we'll be making an object, or what you can do, you can just regression linear regression, we have made an object of this. Now we'll be giving our x train and y train data so that our model may get trained. So for that we'll be using regression dot fit, and here we'll be given our x train data and y train data. Now see our model has now we have trained our model. So what exactly like you can do over here, you now after doing this आपका मॉडल बन चुका है। अब आपको दो चीज़ आपको वो करनी है। हम लीनियर रिग्रेशन में क्या करते हैं, हम बेस्ट फिट लाइन ड्रॉ करते हैं, तो बेस्ट फिट लाइन की एक स्लोप होती है और एक क्या होता है, उसका इंटरसेप्ट होता है। तो हम अभी देखते हैं हमारे मॉडल ने क्या हमारी स्लोप आई और क्या हमारा वो आया है, इंटरसेप्ट आया। तो स्लोप देखने के लिए हम एक वो यूज़ करते हैं, रिग्रेशन डॉट कोइफिशिएंट, एंड फॉर दिस checking intercept we'll be using regression dot intercept. So this is our slope and this is our coefficient 170. Now after doing this, what you can do, you can see like what is your model predicting, and you can plot best fit line. For plotting best fit line, what you can do, you can use sns dot sns dot sns dot scatter plot, sns dot scatter plot, and here you can give x is equal to your x underscore train, comma y is equal to y underscore train. And after doing this, what you can do, after doing this, like this will be given an error. Now per columns array must be of one dimensional, so this is giving us this error. So for treating this error, what we can exactly do, see, for treating this error we'll be using plt dot scatter. So instead of using sns dot scatter plot, instead of using c1, we'll be using plt dot scatter, and here will be given our x underscore train, comma y underscore train. And now you will be seeing like this is our data. And for checking the best fit line, what we can do, we can use plt dot scatter or plt dot plot. You can use plt dot plot, and here what you can give, you can give your x underscore train data, comma our model, that what exactly is our model predicting, like this. Or you can give regression dot predict, you can use this. And for regression dot predict, now you will be seeing like this is our best fit line. And for seeing our best fit line, you can use plt dot scatter x train y train, and x train को regression dot predict x train. Now this will be our best fit line corresponding to this. Now first of all let me make, yeah, after doing this, what exactly you can do, now our model has been trained and you can predict the output for any corresponding test data. So let us predict the output corresponding to our test data. So we'll be using regression dot predict, and regression dot predict will be giving here our x underscore test data, and here we'll be assigning this value to y underscore predict. And now our data has been predicted. Now what we can do, we can check our error by using mean square error, or mean absolute error, or root mean square error. So for that you can, what exactly you can do, you can import these from sklearn dot matrices. These are also known as performance matrices. So you can import that, and then you have to make object of these. Now our object has been made. Now what we can do, we can print all these things, like we can predict MSC. After that we can print our MAE, and after that we can predict our RMSC. So this is the thing, like our mean square error is coming 170, and mean absolute error is coming 10, root mean square error is coming 13. So this is all about building a linear regression model from scratch. And we have seen that if a data set is given, like a data set is given to our model like weight and weight, so what exactly it will be predicting. So we have seen like we have to import first libraries, then we have to read that data frame. After that we have to divide it into independent and dependent feature. After that we have to train test split that data set, and after doing that we have to standardize that our input features, like we have to standardize x train and x test. After doing that we have to import our linear regression model, and we have to train that, and after training we will be getting our best fit line as well as coefficient and intercept, and we can predict the input value corresponding to our test data or any of the data that you will be given. And after doing that you can check the mean absolute error and mean squared and mean root mean squared error, that what exactly is your model doing. So this is all from my side, and in the next video I'll be building some more projects. For that you can subscribe to the channel and like the video if you have earned or gained any of the knowledge from this video. So that's all.